Hello students, hi, how are you? I hope you are doing good. So in this part, we'll be discussing about the introduction of your alcohols, phenols and ethers. So in the introduction, I'll be discussing what exactly is alcohol, what is a monohydric alcohol, what is a dihydric alcohol and what is a trihydric alcohol. Not only that, we'll be discussing about your nomenclature of your alcohols, phenols and ethers. So why to waste our time? Let's start with this part. Introduction. So, in introduction, first let's understand what is an alcohol, what is a phenol and ether. So, alcohols, generally you may find alcohols, I think everyone knows about ethyl alcohol, right? It is a famous reactant in your wine. For example, wine is nothing but an alcohol, right? So, you can see here, alcohols are present in these images of wine. Next, phenol. So, phenol is also very important pharmaceutical reagent, and phenols are also generally used for the purpose of your cleansing, and ethers. Ethers can also be considered as one of the important medicine, and it is used for generally treatment for your cancer. So, what is alcohol? Alcohols are nothing but the organic compounds containing your functional groups OH. Alcohols are nothing but any organic compound which contains your hydroxyl functional group. So, I can say that OH is nothing but a hydroxyl functional group. So, it is one of the important functional group, just like your aldehyde, just like your ketone, just like your carboxylic acid, right. So, hydroxyl functional group is also one of the important functional group. So, if you have an alkyl group and if it is attached, it is being attached by a hydroxyl group, then it is called an alcohol. So, how can I classify an alcohol? Classification of alcohols is based on the number of OH, based on hybridization of carbon. So, I can classify a given alcohol based on the number of OH, and not only that, based on the hybridization of carbon. For example, based on the number of alcohols, I can say that a given organic compound is a monohydric, a given organic compound is a dihydric, and given organic compound is a trihydric. So, mono means what? 1, di means 2, tri means 3. So, monohydric implies that there is one alcohol, dihydric implies that there are 2 alcoholic groups, and trihydric implies that there are 3 alcoholic groups. And based on the hybridization of carbon, right, so there can be alcohols containing sp3 OH bond, and there can be alcohols containing your carbon sp2 OH bond. What is this? Here carbon is having an sp3 hybridization, here my carbon is having an sp2 hybridization. So, based on that, I can classify my alcohols. So, each of this can be further classified into primary, secondary and tertiary alcohols. So, primary, secondary and tertiary alcohols are nothing but if a given organic compound consists of, for example, this is your carbon chain. If my alcohol is present in first carbon, it is a primary alcohol, and if the alcohol is present on the carbon 3, it is a secondary alcohol. So, primary alcohol is nothing but it is attached in the beginning generally, and secondary alcohol, it is nothing but a carbon with 2 other carbons. Here primary alcohol is nothing but a carbon with 1 carbon, and tertiary alcohol is nothing but a carbon with 3 carbon atoms, and you have an alcohol. So, this is nothing but this is a tertiary alcohol. So, C2H5OH is nothing but ethyl alcohol, and it is also a primary alcohol since it is OH, C2H5. So, you have hydrogen, 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 hydrogen and hydrogen. So, it is C2H5OH. So, this is nothing but an ethyl alcohol. which is a primary alcohol. What is this? You have two alcoholic groups, right? So here it is a one alcoholic group, here you have two alcoholic groups. That means it is a monohydric alcohol and this is a dihydric alcohol. And here you have three alcohols present. That is nothing but it will be trihydric alcohol. So yes, it's a monohydric alcohol since it contains one alcohol. It is a dihydric alcohol because it consists of two alcoholic groups, and it is a trihydric alcohol since it consists of three OH groups. Now, based on the carbon sp3 OH bond, that means hybridization of carbon is sp3. So you can see here that hybridization of carbon is sp3. So all these are sp3 OH bonded alcohols. And now here you can see an interesting thing that you have an unsaturated carbon where carbon is sp2 hybridized. So this carbon is a sp2 hybridized carbon and you have an alcohol. So based on the classification, just I already told that it can be based on the hybridization of carbon. So the hybridization of carbon is here is sp2. So it is carbon sp2 and OH bonded alcohol. So similarly, this is also a unsaturated carbon in benzene. So this carbon is an unsaturated carbon. So carbon alcohol is nothing but it is again carbon sp2OH bonded alcohol. So I can clearly say that based on the hybridization, I can classify into sp3OH groups or sp3OH bonded alcohols or sp2OH bonded alcohols. And next, nomenclature. Nomenclature is nothing but naming of a given alcohol or naming of a given organic compound. So what are the common names of alcohols? So common names of alcohols are nothing but they are derived from your alkyl group and you have the word alcohol. So derived from the common name of alkyl group and the word alcohol. For examples, you can see here the IUPAC name of this alcoholic group. That means, for example, the common name is alkyl and the word is alcohol. So for example, you have these three alcohols. So first let's start with the basic thing. So this is nothing but CH3CH2OH. So what is this? This is nothing but an ethane, and you know that you have to replace this E with OL. So it will be ethanol. So what is happening is here is that first thing is you have to understand the name of a given carbon chain. For example, if you just remove your alcohol here, the name of the given carbon chain is nothing but ethane. Now I have to name it as an alcohol, right? Since it has an OH functional group. So you know that you have to replace E with OL, which is nothing but ol. So here it is ethane and I will replace this E with ol. So it is nothing but ethanol. So the IUPAC name is ethanol, and the common name it is nothing but ethyl alcohol, right? Common is nothing but the general term which we use in normal conversation. So it is ethyl alcohol, but I have to follow a given nomenclature, and that given nomenclature is nothing but it is according to the IUPAC nomenclature. So it is ethanol. What about this? Now here I can see that instead of two carbons, unlike here, I have three carbons, 1, 2 and 3, and not only that, there is a methyl group attached to this secondary carbon. So what can I say? It is now, if remember, just keep it your alcoholic group aside for some time and name it. So it will be nothing but 2-methyl propane. And I told you that you have to replace E with OL now because you have an alcoholic group here. So 2-methyl propanol. But the important fact here is that here your position of your alcoholic groups plays very important. So it will be 2-methyl 2-propanol, because here this 2 of your alcoholic group notifies that your OH is present at the second position in your organic compound. So the IUPAC name is 2-methyl-2-propanol. So the logic is simple, guys. You have to first replace E with ol and you have to next find the position of the alcohol. So the common name is nothing but it's a tertiary butyl alcohol, right? Because it is a tertiary carbon, because one carbon is surrounded by 3 carbons and you have your OH group at the second position. So it will be a tertiary butyl, because 4 carbons, tertiary butyl alcohol. So IUPAC rules. So you have to select the longest continuous chain of the carbon atoms containing the hydroxyl group. So I already told you that in your given organic compound you have to select the longest continuous chain of carbon atoms. And remember that longest chain of carbon atoms should consist of hydroxyl group. That longest chain of carbon atoms should consist of your hydroxyl group. So name the carbon atom in this chain so that one bonded to the OH group has the lowest possible number. So you have to start naming your alcohol by giving your OH as the preference. That means whenever you give a functional group as the preference, you will give the least number while naming it. So for example, you can see here that there is a given organic compound. So you have two possibilities. The first thing is you have to select the longest chain. Yes, I have selected the longest chain. This is done. And afterwards, I have two possibilities. According to this second rule, that you have to select the lowest possible number. So one is I can name from this side, and other thing is I have to name from this side. So it is 1, 2, 3, 4, 5. So if I start naming from left to right, my alcoholic group is present in the 5th position. My alcoholic group is present in the 4th position. But when I start naming it from right to left, 1, 2, 3, 4, 5, my alcoholic group is present in the 2nd position. So which one to select? Obviously, according to my IUPAC rule 2, I have to select this, because my alcoholic group is having the lowest possible number of 2, which is less than 4. So select chain as the parent compound, and you have to select and you have to start numbering from here, right? Because if I start numbering from here only, I will get alcohol at the least possible number or lowest possible number. So 1, 2, 3, 4, 5. So 2 is that position. IUPAC rules. So from the alcoholic name, by replacing E of the corresponding alkane by ol, which we already know, that we have to replace E of your alkane by ol. Next, when the isomers are possible, locate the position of your alcohol by replacing the number of the carbon atom to which OH is bonded immediately before the parent alcohol name. So if you have isomers, there is nothing but, isomers are nothing but same molecular formula but different structures, right? So when the isomers are possible for a given alcohol, so you have to just locate the position of alcohol by placing the number, right? Yes, I told you when I told about and discussed about your 2-methyl alcohol, right? 2-methyl 2-propanol. When I was discussing about 2-methyl, right, 2-ol or 2-propanol. So you have to locate the position of the alcohol by placing the number on the carbon atom to which OH is bonded immediately before the parent alcohol name. So name each alkyl branch chain and designate its position by number, just like you did here. You have to designate by number, just like 1, 2, 3, 4 and 5. And after that, for example, again you have this. So here you have to start numbering. So if I start numbering 1, 2, 3, 4 and 5. So this is my second position, and at the third position you have methyl group and it is pentane 2-ol. So you can write in two ways. It is 2-pentanol or pentane 2-ol. This is the most preferred nomenclature. So it will be 3-methyl pentane 2-ol. So examples. So this is the first example we can have. So I have to first select the longest carbon chain. So this is longest carbon chain. So I have to start numbering 1, 2, 3. So it will be what? 2-methyl propanol. And this one, I have to again select the longest carbon chain. So this is my longest carbon chain. So it is nothing but again 2-methyl. It is not propanol now because my alcohol is not present in the primary group, it is present in the secondary group. So it will be 2-methyl propane 2-ol. 2-methyl propane 2-ol. So propane or propan 2-ol. The same thing, yes, it is 2-methyl propan 2-ol. Now you have 3 alcoholic groups, 1, 2 and 3. So it's nothing but again select the longest carbon chain. After that, if I select the longest carbon chain, it is nothing but propane. So once it is a propane and you have your alcoholic positions, functional groups at the first position, second position and the third position, and I already told you that you have to, just like it is 2-methyl propane 2-ol, where 2 represents the position of the alcohol. Now you have 3 alcohols and here 1, 2, 3 represents the position of all these alcohols. So it is nothing but propane 1, 2, 3 triol. So if you have a cyclic alcohol instead of a normal alcohol, you have to use the prefix cyclo. You have to use the prefix cyclo. Now for example, this alcohol, you have bromine here and this is a cyclic alcohol. Cyclic alcohol is nothing but you have a cyclic structure, and to this cyclic structure, for example, this may be also a cyclic structure. This may be a cyclic structure. This may be a cyclic structure. So on the cyclic structure, you have an alcoholic group present. So in the cyclic structure, remember first the hydroxyl group is assumed to be carbon 1. So this will be your carbon 1. So 1, 2, 3, 4, 5, 6. So after this, you have to start naming, right? Since your C1 is selected, once your C1 is selected, you can start naming it. For example, let's start with the basic thing. So once you have selected your alcoholic group and you know this is the carbon to which your alcoholic group is attached. So it is nothing but the first position you have this as a substituent. So it will be 1-ethyl. Also it is nothing but a cyclopropanol. So it is also, right, earlier it was named as this, but there is a latest method where you have to name or where you have to tell the position of your alcohol. So it will be 1-ethyl cyclopropane and 1-ol. Why 1-ol? Because I am already mentioning the alcoholic position. That alcoholic position is 1. And now if we go to this complex cyclic structure, so 1 I have an alcohol and 2 I have bromine. So if I consider the stereoisomerism, it is nothing but trans, because your hydrogen atoms are present at the opposite side. So it is trans 2-bromo cyclohexanol, right? At the second position I have the bromine. So it is 2-bromo cyclohexanol. Since I know the stereoisomerism of this, because I can say this is a trans isomer, to be in specific I can say it is a trans 2-bromo cyclohexanol. And according to new IUPAC, just like I told here, I have to mention the position of the alcohol. So I have to mention the position of alcohol here also. So it will be hexane 1-ol. So friends, these are the different nomenclature concepts of your alcohols, right? So I hope you enjoyed this part. So in our next part, I will be discussing about your nomenclature concept of your phenols and ethers. So till then, stay tuned to our sessions. Take care. Goodbye.